Hi, everyone. Thanks for joining our podcast today. With us, we have John Gammel, who is Principal Application Engineer with our Power and Isolation products. And today he's going to be talking to us about PLC systems and giving us an overview about what those are. Hi, John. How are you doing today?
Hi, Isaac.
For those of us not in industrial manufacturing, can you tell us what exactly a PLC system is and what it does?
Well, preparing for this, I looked it up on Wikipedia, and it gives us sort of an exact definition that a programmable logic controller or a programmable controller is just an industrial digital computer which has been ruggedized and adapted for control of manufacturing processes. This is a little bit hard to follow, and so sometimes I try to think of a simpler application, and the one I often use is a bread factory. In a bread factory, you might have a push button that somebody comes in the morning and they turn on the oven. And then when the oven gets to temperature, the conveyor belt starts. And then, the bread bakers load their bread onto the conveyor belt and all goes well, hopefully. But if the conveyor belt jams, a light will go on to say that the conveyor belt is jammed. Or if the oven temperature gets to be out of control, a warning light will go on to say the oven temperature is out of control. Well, this is an industrial process and it has to be automated. And, instead of every time you need to automate a process, sort of reinventing everything and, programming up a microcontroller to do that process, these programmable logic controllers have existed for many, many years. And they're very standardized and they're very commonly used for controlling these processes. And in fact, there's thousands, if not tens of thousands of factory technicians who are trained in the installation and use of common programmable logic controllers for all kinds of processes. It's not just like the robotic arms you might see on the GE commercials, but it's very often just very mundane tasks.
So, what's the PLC market like?
Well, the PLC market is huge. I've read some market research that indicates that the overall market for PLC controllers is about $10 billion per year. And I've estimated there are about 1 billion U ports installed per year for PLC applications. Now, that's a worldwide market. Not all of our products are going to address into that market. And of course, the electronics content is smaller, but it's an absolutely huge market. The majority of PLC applications are simple DC inputs and outputs. Most factory automation tasks use 24 volts DC for control, and this allows good noise immunity and long wires with minimal voltage drop when delivering power. Some of the advanced needs in the PLC market are analog and precision timing. A lot of the customers who supply in this marketplace are pretty commonly known customers. Customers like ABB, Bosch, GE, Honeywell, Schneider Electric, Panasonic. That's just to name a few. So it's a well-established market. It's very, very large, and it's fairly fragmented in the sense that there's many suppliers who supply into that marketplace.
Yeah, it sounds like a lot of people who could use some help from Silicon Labs. It also looks like a large portion of Silicon Labs, isolation portfolio can be designed into this specific application. And it sounds like if there's all these tasks in manufacturing, I guess, well, first off, can we try to hit on where our power and isolation drop-ins are as far as our Silicon Labs parts go?
Sure. In the programmable logic controller world, isolation is a very standard requirement, and that means our isolation products are going to be an ideal fit into these programmable logic controllers. The isolation requirement can be for safety due to surges that might exist in factory wiring or possible exposure of PLC control lines to high AC potentials. But it can also be for eliminating ground loops in the control bus because different PLC units can be widely separated on a factory floor with significant differences in the ground potential between one location and another location. And so you need isolation to keep your communication buses working well. So we have a lot of isolation products that are ideally suited for PLC applications. Specifically, we've developed our SI8380X isolated PLC input parts, which are designed for conformance to the ISO standards for PLC equipment. We'll also be soon launching our 8340X isolated PLC output parts, which can provide up to 0.75 amps at 24 volts DC on 4 output channels. Of course, our standard digital isolators are applicable in this market, especially our SI88X4X digital isolators with the DC to DC conversion. These are very useful for isolation and power transfer, such as what would be needed with isolated control bus or an isolated analog interface. Our SI8751 EasyFET driver is useful for single isolated switches and can be used to create a controlled AC relay by driving a triac. And of course, our 8 and 32-bit microcontrollers can be used for interface to the control bus or for control of digital inputs and outputs, for example, something like driving a stepper motor.
That's awesome. That's a lot of Silicon Labs power in these, I guess, in a single PLC application. Well, one of the things you mentioned a while ago was bus, and when talking about PLCs, I often hear the phrase field bus. Is this something that Silicon Labs can address also?
Yeah, thanks for asking. The most common control bus for PLC applications is something referred to as Modbus. Modbus is a fairly old standard. It was originally published in 1979 and became a public standard that is publicly available in 2004. Modbus is a simple way to address multiple input and output devices on an RS-485 bus. The RS-485 transceivers output UART data, and UART is a standard peripheral on all of our MCUs. So yes, definitely our MCUs can be used for control of those kind of buses. There are more advanced control buses such as Profibus and EtherCAT. These kind of more advanced control buses are used for higher data throughput and more precise timing. And in this case, our precision timing products are applicable to these kind of bus architectures.
Oh, awesome. Well, how do we enable PLC customers to design in our parts?
Well, the PLC market is a pretty well-established market. A lot of the customers that we'd be dealing with already have PLC offerings. They already have an existing architecture, control bus scheme, and so on like that. So while we're, of course, willing and able to help them in these areas, very often they're just looking for getting higher density or lower cost. It's a mature market, and that's the kind of thing they're looking for. So our PLC input and output parts can be daisy chained together on a single SPI bus, and we can daisy chain for up to 128 inputs or outputs on a single SPI bus. This allows significant density, allowing customers to get to that 128 inputs or outputs on a card. Also, our integrated isolation saves space and helps keep their overall system costs down, as well as ensuring standards compliance. Our other isolation products, and particularly the IsoVolt products with integrated power isolation, will of course again save board space and ensure standards compliance. These also allow easy implementation of other isolated input and output types.
That's great. And I think that's all the time I have right now. But I want to thank you, John, for taking the time to speak to our podcast about our power and isolation products. You also mentioned in the future we will have the PLC output devices, and I just want to mention that if there's any questions related to sampling in Q4 of 2018, you can direct those questions to Asa Kirby, who is our product manager for that product. And again, John, thank you for taking the time today.
All right, thank you.